Hello, and welcome to this Vivado Quick Take video where we will be discussing how to use the advanced encryption standard keys with the battery-backed RAM. Today we'll learn how to set the correct set of properties to generate an encrypted bit file. Then we will take this encrypted bit file and program it to a Xilinx KC705 board. This Quick Take video assumes that you are familiar with setting and editing device properties. We will not be diving into the details of how to do this, so please review the Setting and Editing Device Properties Quick Take video prior to viewing this Quick Take. We will start with a quick introduction on the concept of encrypting a bit file and why you might want to do this. Then we'll look to see how you go about creating an encrypted bit file using Xilinx Vivado Design Suite. Once we have generated the encrypted bit file, we will look at how to program the encryption key to the battery-backed RAM, or BBR. After we have successfully programmed the BBR, we can then configure the FPGA with the encrypted bit file. You can protect intellectual property, or IP, in your design by encrypting the bit stream with 256-bit AES keys. You go about this by loading the 256-bit AES key to the FPGA's battery-backed RAM before you go ahead and download the encrypted bit file. Let's take a look at how we go about setting the correct properties for generating correct bit streams. We will open up the synthesized design, then open the Edit Device Properties dialog. We will then look for the encryption selection, and now we need to change the Enable Bitstream Encryption to Yes from No. Please note that No is the default. We will also need to confirm that the location of the encryption key is set to BBRAM and not eFuse. Vivado will generate a random 256-bit AES key for you if you leave the rest of the options in default. So let's leave these options in default, save, and close. Now we need to save the constraints and run through implementation to generate an encrypted bit file. Now that we have completed the implementation and have the encrypted bit file, the next step is to ensure that we program the BBR key. Right-clicking in the target part of the Vivado Hardware Manager will give us an option to program the BBR key. We need to point to the encryption key file and program it into the BBR. After we've programmed the BBR, we can now configure the FPGA with the bit file. First, we'll select the device target to program, and then select Program Device. Now point to the encrypted bit file and click on OK. Before we take a look at the demonstration, let's take a quick look at the hardware we'll be using today. Pay attention to the configuration mode setting dip switches, as we need to ensure that these are correctly set. The KC705 board has multiple configuration mode capabilities. We will focus on setting the JTAG for this demonstration. Let's make sure that the dip switch setting is set to 101 before we turn on the board. Please refer to the KC705 Evaluation Board for Kintex 7 FPGA User Guide for more details on how to do this. Now let's put all this into practice. I have a design opened up in Vivado here, and we're going to start by opening up the synthesized design. Once the synthesized design is opened, we need to go to Tools and Edit Device Properties. And this will open up a dialog. So let's select the Encryption tab. Here we need to ensure that we enable bitstream encryption, so click on the drop box here and select Yes. Next, we need to confirm that the location is set to BBRAM. Now, let's ensure that all the other options in the Encryption tab are set to default, so we're asking Vivado to generate a random 256-bit AES key for us. Now let's close out the dialog by clicking OK and save the constraints. Now let's confirm it did actually save the constraints to the XTC. So we open up the constraints file and confirm. We can see that the property being set for enabling bitstream encryption. And next we need to ensure that the design is DRC clean before we run implementation and bitstream generation. So we click on the Report DRC button and select the defaults and click on OK. So there's no violations found, so we can proceed generating a bit file. We'll click on the Generate Bitstream button. This design was already implemented with the default options, so I'm going to go ahead and click on Yes to rerun implementation due to the change in the XDC. Now that the implementation is complete and we have a bit stream generated, we can open up the hardware manager. Let's start by clicking on the open target in the green bar, and we'll go ahead and select Auto Connect. Auto Connect means that I have the board connected directly to my machine, so it'll connect to the board first. After connecting, the Kintex 7 325T can be seen. This is our target device. We will go ahead and select the device and go to the Properties tab. Let's search for mode in the search window. After expanding the window, it's clear that the mode pin has been set to 101 to use JTAG mode. Now let's go ahead and configure the encrypted bit file to the FPGA. The dialog box has already pre-filled the bit file that is part of your design, so no need to make any changes here. We can click on OK. Notice that the programming failed and the done pin did not go high. This is because the bit file is encrypted, so we can ensure that someone cannot take our encrypted bit file and try to put it on their own hardware or steal our IP. So let's go ahead and program the BBR with a key and try this again. We program the BBR key, then we go ahead and select the key file from the dialog. We can confirm that Vivado recognizes the key, and thus we can go forward and program it by clicking OK. Based on the messages, we can confirm that the key has been programmed. Now let's try to program the encrypted bit file. So we right-click on the device and select Program Device. Select the same encrypted bit file and click on OK. So this time around, we can see that the programming was successful and that the done pin has gone high. So let's recap. We've learned how to use Vivado Design Suite to generate an encrypted bit file. We learned how to program the encryption key to the battery-backed RAM. Then finally, we learned how to configure the FPGA with the encrypted bit file we created in Vivado. So please refer to the Quick Take videos Setting and Editing Device Properties, as well as Vivado Design Flows Overview for a general understanding of the Vivado flow. There are additional instructor-led training offerings as well if you're interested in learning more. The following 2 user guides go into deeper details on the concepts we covered today and many more. And those are UG908, which is Vivado Programming and Debugging, and UG835, which is the Vivado Design Suite Tickle Command Reference Guide. Thank you for watching this Vivado Quick Take video on how to use the Advanced Encryption standard keys with the battery-backed RAM.